All right, Joe, welcome to the Unicorn CTO Podcast.
Thank you. Excited to be here.
Yeah, I'm very excited to have you on the show as my guest number one for the revamped edition of the podcast. For listeners who don't know you, you're currently the Chief Technology Officer at Red Canary, a computer security company that was recently acquired by Zscaler, and you had quite an extensive career in computer security. So we're going to explore what you did during the show today, but also I'm very interested to understand your views on leadership and technology and how you were able to manage software engineering teams without having yourself a developer background, though you did tell me that you code a little bit. Without further ado, actually, I'm going to start with my first question. So how do you go from working in a big retailer, being in charge of security, going from physical security to data security, to joining a startup?
This was about February of 2014, and the Red Canary original webpage is up. The company had just incorporated out of a defense contractor called Kairos Tech, which is also where Carbon Black had originated from. I looked at the website and I looked at like, hey, the leadership page and everything, and I recognized Phil Hagen, who was listed as the CEO at that time. And Phil I tangentially recognized because Phil is also very active in SANS, which is a big security training group. They do a lot of really good work. And through recollection and conversations later, I realized that I had met Phil many years before at a SANS conference in a forensics class I was taking. Phil was just getting started with that and in that program. I said, okay. So I talked to Phil, said, hey, here's what I want. I'm thinking either career reset or I want to go build a security program. I want to go build a security operations program, what I consider the right way. I said, I have all these ideas. Here's all the things I've learned over the years of my career. Here's where I think it's inefficient and where it makes employees sad. And we're kind of thinking about this the wrong way. He's like, great. We really need somebody like that. He's like, when do you want to start? I said, well, I got this retention thing. I'm like, working through that. And so we kind of went back and forth for several months. I was trying to finagle out, trying to actually finagle out how I could keep my retention and come work for Red Canary. It didn't kind of work out that way. So I finally said, okay, you know what? I need to pull the ripcord. I'm going to just go do this. Joined Red Canary. That was like June of 2014. And at the time I was the 9th employee,
That was before the first fundraising, right?
Yeah. So they had seed funding, but that was it. So it was super scrappy. There was 9 of us doing this. It was kind of, nobody's done a very early startup. You wear all the hats. Through going through that, I learned I really don't like being an SDR and making cold calls, but I did that. You had to write some code. You had to go clean bathroom. You had to kind of do a little bit of everything, and everybody kind of did everything, which was a really interesting experience. It gives me a lot of respect for, for example, the grind of and the grind and the career growth of a salesperson. That's a hard ladder to climb, and more respect than I ever had, having learned and seen kind of some of that things and some of the other aspects. But it also gave me an opportunity. It was, from the ground up, hey, how do we want to think about security operations? How do we want to build and kind of do these things different? And it was taking, hey, my early days at like the Motorola SOC and doing other security operations, and how did they think about it, and what did I see that didn't work? And even going back to my undergrad in manufacturing systems and even some of my time at Motorola, thinking about like things like lean manufacturing and Six Sigma, and how do you apply these ideas of reduction of waste and efficiency and optimization to the security operations job, which was part of the idea. Plus, we had all this new technology in EDR. We were largely at the time Carbon Black, was our primary data source. So we had this new rich data source that we were working on to do the detection, to find the bad guy, find the bad behavior in data, new visibility, and this opportunity to kind of rethink how security operations, how you structure those teams, how you structure the work, and how you do that. So it's applying like, hey, how can I think of really new and novel ways to change how we're working to get, a faster or better or improved outcome. I was very motivated early on, like, hey, how do we drive gross margin? So it was a fascinating problem. Like, give me the spreadsheet, let me figure out where the inefficiency, where are the cost savings, how can we squeeze a little bit more out? And it was those type of ideas that helped me be successful in other things like engineering.
So Hold on. First of all, you're one of the very few CTOs that talk to me about gross margin. There are others. Can you tell me what you did around that? So why, first of all, is it important to focus on gross margin when you run engineering? And how do you improve that?
Yeah, so for us, gross margin, being a kind of security services or tech-enabled services, early on, most of the existing firms and companies and everything from a valuation and a growth perspective were in an managed services model, which had low margin. And so from like an investment perspective and doing fundraising and trying to grow enterprise value, many investors would look at it and go like, well, your fragility or your risk is on people, because they look at it and say, hey, your linear growth is you're looking at a linear growth chart of people and customers. And so we wanted to get to a non-linear growth. We wanted customers to grow much faster than people did. And so from that that was kind of where we started thinking about it. And so it was, how do we build a profile as a tech-enabled service that looks like a SaaS product, or as SaaS-like margins? So that was part of our core idea as a company early on. And so that was initiated. And so early on, it was from the people side on the security operations. How do I think about, because our gross margin, which is basically how I had a CFO describe it to me, and I think this is a great way to think about it. Your gross margin is a measure of your scalability. And that's really to think about it, because how many dollars are you going to retain for every dollar a customer pays you? And so that's what you're trying to maximize, because those dollars retained are dollars you can invest back into the company for innovation, for growth, for all those things. So that's why, as an engineering leader, as a technology leader, as a software executive, gross margin is really important. It's effectively, how do you measure how fast you can scale?
So let's pause here just for 1 second, especially for listeners who are not comfortable with the concept of gross margin.
Yep.
And I'm really happy to talk about that. Gross margin is the difference between revenue and the cost of goods sold. In a pure software company, the gross margin is very high, up to 80% or more, because you build a software once and then you can sell it indefinitely.
Yep.
Basically, you just need to maintain what you already sold, and that's usually 20% of your engineering workforce that's dedicated to bug fixing and maintaining and some residual infrastructure costs. But when you're in managed services or MDR, you sell human beings. So that's why your gross margin decreases, because you have a fixed amount of humans that you have to increase with the number of customers that you have. So your job is actually more complicated than a pure software company, yet you are raising funding at, hopefully, software valuation. So how do you make that stretch?
Yeah, and that was exactly the problem that we always were looking at. And so like early on, we had two core levers that were the core parts of our gross margin story. One was the security operations piece, was like, how many humans does it take to deliver the service? And the other side was our data processing costs. So we have a very large AWS footprint and now some Azure footprint and some GCP footprint, but like data processing, and part of our original hypothesis, from a security operations perspective, coming from, the early Carbon Black, is we wanted as much data and as much visibility as we could, so that we could optimize finding as effectively as possible the bad things going on in a customer's environment. So we're processing tremendous amounts of data and coming into up until we were going through we're pouring in like petabytes of data on a daily basis, just chunking through this. And so there's a fixed cost with that, from the overhead, both of engineering and then just like your AWS bill, and you manage that as part of the service delivery. But then yes, your other pieces, your humans. And so those are the two levers you had to optimize. The third lever you kind of have, it's kind of actually was a triangle for us. Is then also your pricing. How much are you selling it for? Because the more you sold it for, you could adjust, you could lever the margin, but you only have so much control of that because of market dynamics. The market's only going to pay a certain amount, and there's a certain standard by which that value hits. So you don't have as much leverage there. So your optimization is, for a managed services, how do you squeeze the most out of your humans, and how do you make your data processing as efficient as fast as possible. And that's what was really cool. And the team that we had was really good at those problems. So I did a lot of the human process side of things, but then we also, the early team, especially Brian, who was CEO, and Chris Rothy, who was originally our CTO and was one of the co-founders, were very much on like, hey, we should make as many jobs as possible done by software. So that was a lot of the hypothesis. As Joe, hey, how do you do security operations really effectively? Okay, cool. How much of that can we do via code, or enable via code? And it was a fascinating idea to me because like, okay, if I can drive it out in a flow chart, I can probably make software do it. And, it can make anywhere there was a clear, decisive decision. And so that's a lot of what we did. And then enabling, trying to always get to making the number of, kind of units of human needed to make a decision as small as possible. Or how do you take a human decision and you apply it, multiple times. So, hey, I can make this decision once and apply it hundreds, millions of times. And so that's a lot of what we did. And that's a lot of, was constantly optimizing, in our workflow. And so we built the technology and the platform. At the same time, we built a team, which I think is one of the things that allowed us to be really effective at scaling the human side, because we could look at the inefficiencies in the human process. Where is this taking humans more time, more effort, more cognitive load? Where are they making, repeated decisions? And then apply that, build that into technology. Like, for example, we had this idea where we would identify something bad in a customer environment and we would tell the customer about it. And then we'd later get follow-on activity, but it was still related. It was still an open investigation on the customer side. And so, but that new activity had to be added to the story. And we came up and we said, hey, we already know what this looks like. So once we've identified it, can we write some basic rules and some basic logic to then just automatically add that and keep that story going on, instead of a human doing it? Like, cool, this is a great idea. So we sat in a room, we whipped it up in code. What was surprising, we kind of had our ballpark, but like this was I think we call it auto append bot, because like automatically we like to name things by what they did, which is a great, like, I think for all CTOs out there, from a technology decision, name your technology, name your code based on what it does. It makes like handoff and learning so much easier. Skip the code names. But we did that and it reduced our workload at the time for our analysts by about 50%. Just like with one code change, because we realized how much like just kind of busy work, or if you want to use like SRE terms, how much toil we had in like on the security operations side that we just wrote into software. And we're like, oh, that was fascinating. How do we do this? And so, by the time we got to like the Zscaler acquisition, if you looked at the data and the investigations and the pieces we were doing, it was 95, 99% of all of the work that would have normally been done by human was actually done by software. And it was just this last leg was done by humans. And it's still a lot of volume done by humans, but like on a relative scale, when we started off, we used to measure it as, units of Red Canary per human was kind of our human measure. And it was just easy to spreadsheet and easy to kind of predict. And like, okay, looking at a sales forecast, how many people do I need to plan on hiring? And early on, we were at like, 2,000-3,000 units of Red Canary per human. So every 3,000 units we'd buy, and you think about, so that's about, 3,000 units is about a 3,000 person company. So that size contract, we'd have to hire a new person. So from a growth, it's like not a pace of hiring you want to be on. When we're now, I think we're probably 200,000-400,000 units of Red Canary per human. So like when you get your growth is, making that nice hockey stick shape, or your hiring is very low and slow, which allows you to hire selectively, hire really top talent, do any of those things. The other thing we learned through some of that and some of the things we applied is that because we, the things we put in place from the technology perspective, but also the jobs we allowed the humans to do. So part of the original hypothesis was, in a classic security operations model, it was very much like a call center. There's tier 1, tier 2, tier 3, and tier 1 could do kind of basic triage, and then they hand it off, and then they hand it off. And you had separate teams that were doing, kind of building the logic, the detection logic, and building all that stuff. We flattened all that out. So people doing the analysis were also building all the logic. And so they kind of controlled their own destiny. which the original intent was from a retention and happiness perspective. Because like as a as an early SOC analyst, that was always my frustrating thing is the guys building all the logic were basing it on historical knowledge and historical experience, and they weren't seeing the real-time data that I was seeing. And so there was always a friction there. And so we wanted to reduce that friction. Well, that friction allowed change. One, gave us really good retention. And so the other thing from an employee retention, you're saving costs there too, because you're not having the kind of the sine wave of training somebody up, getting them optimized, and then having, kind of bringing in, you had this, effectiveness that retained. And so you got a lot more value out of an employee. And the other thing is that we found it contributed to more of that scalability because the team was encouraged just from a intrinsic motivation to make this as effective as possible, to make this, because they had to eat their own dog food. And so like, I don't want to create garbage work for myself. So I'm going to be really effective in the work that I produce and do, which helped drive some of that scalability and everything else like that. And then early on. So yeah, so that was how the human cost side got optimized.
Let me interrupt you here because I've dealt with humans before, and I know that usually humans ask for more humans. So whenever you throw more work at humans, their first reaction is we need more humans. So how did you manage to change this mindset so that the humans in your team were actually incentivized to ask for more automation instead of asking for more humans?
So part of it was a couple things. So one, it was, creating interesting challenges. So finding a lot of it was the hiring process. So early on, it was always it's how I think about team building. And so I like analogies. And one of my analogies from team building is I think about it like soup. I love to cook. And so soup is a great analogy. You start with a really strong base. So if I'm building a security operations team, I need some really strong generalists is my base. And then as we're looking at the work coming through, I need specialists to augment them. And the idea in this team was instead of that tiered model and separated specializations, it was this kind of hive mind idea. In a typical call center model, you're measuring individuals based on like tickets or units they produce. I wanted to switch that and look at it more like a system. And so as a system, you're measuring the inputs and outputs. And that team is a processing unit. And if you think about it like in a software architecture diagram, it's just one processing unit or a couple processing units. And so you're like, how many units widgets am I putting in for how many widgets am I outputting? And so that's what we started measuring. And so it was measured on team performance versus individual performance. We still had some like individual performance stuff from like, because you have to have some that, to make sure your people are doing, but the things we reported out to the business and how we measured the team was, and as motivation is like, hey, you as a team have to figure this out. So the team was optimized for like, okay, cool. Now we have an interesting problem. So you created interest in the problem to solve. And so again, it's thinking about that team building. So one, you have this strong base, but you're also, how are they intrinsically motivated? Hey, I wanted people who were, naturally curious, naturally like to pull things apart, really wanted that kind of investigative mindset. I could teach people how to do security. I can teach people to write software, but I can't teach people to think. And so I needed people that had a natural kind of, that kind of hacker mentality. Like I like to take things apart and put them back together. I like to know how they work. And so did that, and then finding people that had the different skills I needed to augment that. Oh, I've got my strong base. Oh, now I need a little bit more forensic knowledge, because hey, I'm pulling more out of leadership. And so I need somebody to fill in like really deep in OS internals. Hey, I need somebody who thinks like an attacker versus a defender so they can kind of, bring a different, and you keep doing that. Oh, I need somebody who's got more software development skills. And so you keep adding that to the team, and then you give them this interesting problem. And that's the other side of it was we were, as a private company, we could be full kimono on financials and everything. It was like, hey, this is what it means to you as an employee, as a thing. We want this company to succeed. We want this achieve this mission, which our mission was, it buried in phrasing, but basically we wanted to remove the risk of cyber threat from our customers so they could do whatever their job was, so they could achieve their mission. So our mission was to empower other companies to do our mission. So again, from that motivation of people, have a very mission focused people, very curious people, like, here's the mission, here's the way we can make this go faster. It's not about sales, but it's about reducing this cost so we have more to invest. That gives you more people, that gives you more tools, that gives you more things. We have to in kind of showing that and putting that as some of the goalposts for them, and hiring the right people with the right kind of motivated mindset. They're like, cool, I don't want more people. I want to figure out how to solve this puzzle and do that. And you just kind of, you get it rolling, and then it just kind of, it snowballs, and that team runs, super effectively and doing that. And eventually they do get to a point where like, okay, we don't think we can add, do this, we need a few more people to help, or, hey, we need some other skill sets. And you do that, kind of surgically and in a targeted fashion. But by showing them and training them, that was one of my favorite things to do. Was like, I'd bring in a new security analyst, and one of the first things I'd teach them is basic SaaS metrics. Like, here's what gross margin is. Here's what, cost of sales is. Here's what ARR is. Here's how this works from a growth perspective. Here, this works from a valuation perspective. Here's how, why supporting our sales team is advantageous to you, and what it means to your bottom line, what it means to the company, like all these things. And it made a much more educated employee and a much more motivated employee, because now they'd see like, hey, the salesperson comes and says, hey, I need your help with this. It was like, oh, these sales guys always, it was like, no, cool. Hey, how do we achieve this mission together? And it brought this very kind of one team mentality, which again, I think was core to the culture and core to our success.
So how do you apply that to software engineers who are very different animals than security analysts, especially without having, and I don't want to put some imposter syndrome upon you, but without having that software engineering background yourself? So how were you able to basically take over the software engineering team?
I think it's two pieces. One, again, looking at how I think about org development and team structure, the way I've always approached like org development, or I've learned to approach org development. So I go in with no ego. I always look for, like, when I'm looking for, building a team or improving a team, I first look at the leadership. I think leadership is the key to a successful team. And I think about it as like, the way I've described it to others is like, it's a matter of blast radius. An individual, an IC at the front line has a much smaller blast radius. Like, they can have a really big impact, but if they make a mistake, the blast radius or the impact of that mistake is fairly small, because, they have a certain scope. The further up you're in leadership, the bigger that blast radius is. So my time isn't any more important, but if I screw up, the impact of that is much more significant and impacts a lot more people. So in order to deflect that is, how do I scaffold myself and the team with really effective leaders in and around me? How do I, and so, hey, I don't know anything really strong software. So how do I augment my knowledge and find somebody who really knows that? And so I want somebody who's so smart at the job that I need to take over, I need to manage, that they make me uncomfortable, that they might displace me. And if I get that level of discomfort, I probably got the right skill set and the right knowledge. And then I have an honest conversation. Here's where I need you to manage up. Here's what I need you to be accountable for. And here's what I'm going to bring to you. Here's the knowledge I'm going to train you. Here's the knowledge I'm going to do. And here's how we're going to work together. And it's a team. Like, I'm very transparent with my people, very transparent, and I expect a lot of upward management. And so, hey, I need to find people who know software engineering practices really, really well to support me. I know how to scale. I know how to build teams. I know how to build efficient processes. I know ways to identify inefficiencies and everything else like that. And then the two together, I can say, hey, here's the problem. Here's the outcome I'm looking for. How does that get applied in software engineering? And here's why I'm trying to do that. And so doing those things together, you can build you can solve these problems, and it can be really effective. And I've seen other leaders, with the similar practices go from like CTO to CRO to CPO, and because, they can apply, they know what they know, and they know what they don't know, and they can look for those supporting people, that scaffolding to build that up and support the team up and down. You can do that. And so that's a lot of what I did. It's like, okay, who do I have? Who's the kind of the rising star? Who's got interest in who's either a really good software engineer and is interested in leadership and asks the right questions. They're like really curious about, motivating people and giving feedback and hiring and everything. Like, okay, cool. Like, you're great management capacity. Like, let me pull you up, and do that. Or, you find really strong IC leaders and stuff, architects and principal engineers and everything. It's like, hey, this is what I'm trying to achieve. Like, what does that look like in software? and everything like that, and leveraging those resources and doing that. And so that was a lot of it. And so I could come in and go like, hey, looks like it takes us, our velocity looks to be kind of slow in these areas, and are we doing this? And they're like, well, yeah, and here's, okay, well, why are you doing, asking a lot of questions, and then challenging norm. But one of the things like we had is, coming through the other side of, COVID and everything, and the kind of compression of the market and everything. Hey, I don't have a lot to invest in more engineers to get more work done. So how do we think about it? Oh, look at our product portfolio and everything. It's really one product. So do we need kind of durable or product aligned engineering teams? Hey, could we do it more functional and do a swarm model and everything else like that? And so doing that plus, improving our measurability and our throughputs and everything like that, which is some of its core agile principles and, things like that, but like being more deliberate about them and more transparent about why we're measuring those to do that. And then being really targeted of like, okay, hey, how can we continue to shift these limited resources and swarm on different problems, allowed us to do the same, with the same size team, get to 3 and 4 and 5 products that we're actually doing. And now we're at a size and scale where, okay, now we should go to, more durable teams because it causes other problems or other inefficiency upstream, but like challenging some of those norms and having some of that debate and conversation and doing that and just being curious because I don't know, which was actually a good asset in these spaces. Like, hey, I don't know software engineering. I know how kind of like code works, and I know some of these systems, and like I know how this platform is architected because I'm very close to it. But like these other core principles are new to me, so I've got to be curious and ask questions. And by me asking questions of really strong leaders, it forced them to think about and explain, and I could challenge it in a way that didn't create a lot of friction or consternation, because it was literally just Joe being curious and Joe having ideas and everything. Like my team makes fun of me because I'm very much a visual talker. I wave my hands, I have all sorts of ideas, but like that, that dynamic with the team help them apply that. And I think and then also like, the people who came before me also set up a lot of, like I said, Chris Rothy was one of our co-founders, was really the CTO, awesome systems engineer. And so like I understood systems, he understood, applying them in software. And so had built a really good foundation. I was just, hey, how do I take that and run that forward? So it was kind of a combination of things that allowed me to do that. And then doing that for a few years, now I at least have I'd say a passing understanding of software engineering practices, engineering team size and scale, and how do you implement these things, and where do we have challenges? How do we better interact with product and product management? How do we get engineering plus product plus an operations team, which is not normal in a software organization, to all work together, all do planning together, and kind of apply strong processes and strong, looking again for inefficiency and squeezing the most out of the resources we have, and then teaching those skills to them people that know the specializations pieces.
So you mentioned swarm teams, which is a bit controversial in software engineering. There was the infamous Spotify model that Spotify doesn't use anymore. So
Yep.
can you explain a bit more what you did around swarm teams, and did it work or not?
And so what we did was basically we kind of had your standard from like an org development. You have a span of control idea where you have like one engineering manager to 5 to 7 engineers and everything else like that. And in a product oriented model, you'd have them all, they'd own a product or a feature, and that's what they focus on. They work with a PM, and like they just own that through a backlog and everything else like that. With the swarm model, it was the way we implemented is we ended up with two sides. One, because we're dependent on third-party software or third-party data. So we had an integrations team, which was just like, hey, how do we get data in and work with that? And then there was the platform team, which was like the underlying system and everything like that. And it was the two, and then we just had these two big blob engineering teams effectively. And so you had like on the integration team, you had two or three engineering, actual full engineering teams, same thing on the platform side. And so instead of them being on a specific feature, oh, hey, you're going to do our endpoint stuff and you're going to do our automation stuff and you're going to do this. We said instead is from a planning perspective, because we were running lean, it forced us to prioritize more broadly. And we had to prioritize across the whole platform and the whole portfolio but then we could take as many engineers as we could kind of fill up and put on that to go as fast as possible. And so you would swarm all these engineers onto one problem to drive it as quickly as possible. And so you had a smaller number of priorities, but you would move them faster. And it forced the team to be more, kind of forced a little bit more of a generalist approach because you're looking at aligning your engineers almost on skill set versus, versus like a product or a product specialization. And did it work? Yes, it did. It worked until it didn't work. And so like, and that's why I say like early on we had multiple SKUs, but we really only had effectively one product. And so we could do that as we expanded our portfolio into multiple products. Now you're running into challenges of you're starting to put revenue targets on those multiple products, on those multiple offerings. You're increasing complexity of the system and everything. And so that ability to swarm and move things to change the dynamic on your prioritization, and hey, we need to grow both of these because we need to grow our net retention. So we need to have expansion opportunities in by selling more products. And so we need to have new revenue targets and new features and new demands on these other plus we have to support the core. And so when you get to that, then it goes, okay, now we have to change the model so we can do that prioritization and put targets on individual things. And that's where the swarm model breaks down because now your trade-off model or your prioritization model changes. But leading up to that, when you're prioritizing a kind of a single threaded, it worked really well because you could be really efficient and very precise on like, this is the most important thing, just go do this. This is the next most important thing. Now you kind of have to break that up, which it creates you need more engineers in order to support that because you're supporting more products, but it's natural growth and reinvestment in R&D and everything else like that. And so identifying that inflection point, which for us was really when the size and the shape of the product portfolio changed, we needed to adjust how we staffed engineering and thought about engineering to align to that change in product portfolio and kind of business profile and how we were selling what we were optimizing for.
Yeah, I love how you are tying organizational design with business objectives like net retention rates. So that's really interesting. Joe, we're getting to the end of the podcast. I still have a few more questions for you. You mentioned systems and systems engineering, and it's not common for people with software engineering background to know systems very well. How did you learn about systems and how would you recommend CTOs to become better at systems engineering? So maybe books to read or things to do.
So I learned about it from, originally it was like that undergrad program of like learning manufacturing, because that's all systems. It's all, you look at things like Kanban and Lean and Six Sigma and Toyota manufacturing processes, then going into Motorola, which at the time was everybody had to be working towards their digital Six Sigma green belt. And you were really cool if you were a master black belt and like everything was around like how do you tear it all down and put it together more efficiently? How do you reduce the number of defects? All those type of things. Which to me, naturally, when I got, around software engineers and everything, this just makes sense. You have, raw resources or thing, and you're producing an output or a product or an offering for customers. And like, you want the least number of bugs because that creates the most rework. You want the most speed to delivery. So like a lot of these concepts seemed very natural when I started applying it. And again, I give credit to people around me, like, Chris was a great software engineer, but he was very much a system thinker. He was trained like as electrical engineer, and his dad was an electrical engineer. So he thought about it from those things. And so he was really about streaming these things together. But like it's laying out kind of that process or that workflow or kind of those models. So people looking to learn that, I think it's learning from the core systems. Like look at manufacturing stuff, manufacturing and like really high, highly effective manufacturing programs. This is what they eat, sleep, and breathe because they got razor thin margins and they got to get optimization. You get all the ergonomics of the employee and how do you like where do you put a button in order to get them the least number of clicks and everything like that. Like that's one play, so it's learning from those systems. Like, there's like the Lean Institute and there's all the Six Sigma and like, in even the Andy Grove book. I mean, you have all of those those system thinking things. Looking at Toyota manufacturing and like the original Kanban system and looking at kind of like, and if you kind of pull back and you zoom those out enough and look at kind of the streams of those things, it's all data processing. It's all this it's all the things that most of us do from a, software production perspective. It's just like, oh, I just understanding these basic premises and concepts. That's like where I would start. So like looking at some of those basic kind of 101 things, and anything in the industrial engineering space. Disney is a great example. Disney is very strong industrial engineering base. It's all about optimizing how many guests can you get through the ride lines in the most amount of time to maintain the experience and everything else like that. And it's all about that optimization of like time studies and everything else like that. The other thing I think is really important for CTOs and software engineers and everything is go observe your users. Like, and it's not only like from a user experience, but like, where do you see inefficiencies? Like where, if I look and like, oh, it takes me 12 clicks to get to this thing, does it need to be those 12 clicks or can I do it in one click? And so you start thinking about it from user experience too. And like, how can I get to that point of value faster? And you start, and thinking about that and reducing the number of steps. And so it's a lot of it's observation and just kind of taking a different optic. But like I said, I think anything in that manufacturing space is a great, and like I say, you kind of go to the Andy Grove, world, and like that's kind of everybody points to, but it's a great example. Like even those first few chapters of like, hey, you're producing eggs and doing this, and it's going through like that's it at its core. It's that kind of concept, and if you can internalize that and start applying that, it really brings some ideas. And even core engineering things like Agile, it's built into that. You're talking about backlogs and velocity and story points. It's like, yeah, it's all an optimization exercise. And
the book about the book from Andy Grove you're referring to is High Output Management.
Yes. Yeah. I'm drawing a blank on the title. It's like, no, I can even visualize the
drawing with the eggs. Yes.
Yeah.
And I think that one great book about Disney is The Disney Way.
Yes.
Where they talk about leadership and management and operational.
Be Our Guest is one I highly recommend to people, which is an interesting way to frame user experience or customer experience. So I think I think customer and user experience is super important for engineering and high tech folk to really think about, and it's maybe not the natural thing for them to think about.
My last question for you, Joe, is about AI. I have to talk about AI.
Oh, everybody has to talk about AI.
And what's really interesting is that when we're talking about your security operations team, you mentioned humans and you mentioned automations, which for me, I directly thought about AI agents.
Yeah,
so
exactly.
how are you thinking about agents today, and how are you envisioning the potential replacement or enhancement of humans with agents?
So I think about it. I think about AI as just it's high powered automation. Kind of when the whole hype of like AI is going to replace humans. I don't think that's the case. I think AI will change the jobs that humans do, and it'll change the capacity of a human. So like I use the analogy of the Industrial Revolution. Like the cotton gin didn't replace humans, but it made the throughput and the output and how humans work much different and much more effective. I think AI is the same thing. And so that's my basic, high level principle on AI. The way we've been using it actually for several years now. And the idea is, again, we use it as an automation or an efficiency gain primarily. And the idea is that, because of, one, how AI and specifically like LLMs and things can present information, it's a much lower cognitive load for a human to consume the output because it writes all those large language models and everything output in human readable text. Like you can take a JSON blob and it converts into like a couple sentences. It's much easier. It's much lower cognitive load for humans. So like if you're talking to an engineer, it's like it's that many less CPUs or RAM that you have to do on your AWS bill to get the same output. That's one aspect. The other idea is like we think about, and we've done some talks about this, is like the way we're applying agents is each agent has a job, and a job, it's not replacing the whole human job because if I break down my job, if you look at my job description, there's 8 or 10 or 12 bullet points that I have to do my job. I can take one of those bullet points and I can delegate that to an AI agent. Hey, in the security space, hey, I need to go do a, basic enrichment on this alert. Well, what do I need to do? Well, I need to extract some fields out of it. I need to go look up some reputation information. I need to contextualize that in the scope of this customer. Each of those steps, I can have an agent go do. Go hit this data store go look up the information ahead of time and then summarize that information back to me and have it ready for me when I get there. So, and since it's non-deterministic, you still have to there's like a observation or training. And we think about it like an employee. Like a new employee comes in, and the first thing they do is they shadow. So you just have your agent and it's following the human doing that job and learning. And then, okay, well, now you switch. Now it's the trainer is following the thing and then, okay, making sure and kind of providing feedback. And then at one point, then it goes off and you say, okay, you're now been promoted to like, you're off of training, you're off of, you can go do your job. And so now you have an agent that says, my job is to go triage this specific type of alert. And that's my job. That's what I do. And I produce that output, which is a really good boon for, again, in the same idea of, applying human decisions and everything. It's cool. Like I've trained this thing to go optimize and do this one piece of my job for me and provide. And I have confidence because I've trained it and I review it and I do QC on it regularly. I give it a performance review and everything else like that. So, and I can keep stacking those things together. The other thing that's really interesting in like agent-based architecture is agents can talk to agents. So I think about it almost like a pyramid. So I have a agent, like I have 5 different steps I have to do in a process. So I send all those agents and each agent does one of those steps. Then it all feeds up into kind of a master or parent agent and says, hey, here's all my findings. And that summarizes all those and it gives it to the human. The human goes, cool. But the human still needs to be able to, the one thing that I don't know that everybody always thinks of, there still has to be an audit trail. There has to be inspectability to validate because again, all these agents and AI is non-deterministic. And so we have to be able to kind of check their work and do a QC aspect. And so like some of the ways I've been thinking about is like, hey, we want engineers to go build agents for jobs, but then we want to give those agents as tools to, in the same kind of way we thought about like detection engineering and analysts. Now you have all these tools. So instead of, building analytics and looking at the output, now you're going to stitch together agents and you're going to QC their output. Similar kind of, it's again, I base it all like, I love the SRE model of the kind of operations and software development. It's like you have 2 jobs that complement each other and you have to kind of do both. And you're kind of tweaking and adjusting how much you're doing it. But that's the way we think about it. So it's kind of, how do we keep breaking down a job? Or it's that system thinking. How do you keep breaking down all the component pieces of the job? And which ones make sense for an agent to go do, optimizing that agent and being very specific for that job. Then agent has one job. The other thing, if you're talking, software and software architecture models, it starts looking a lot like microservices in that same kind of analogy and premise of like, hey, you have one service that does one thing and it communicates to another system, and you have all these ones. Agents is a lot of the same thing. And I think that's the one caution now, having been around software engineers and seeing everything, is like, we have to be thoughtful and learn from previous things like, runaway microservices and having way too much microservice architecture gets really hard to troubleshoot and understand. We got to be thoughtful about that on agents. Like it's going to be super powerful and it's going to make us go fast, but like, let's again, not make some of the same architectural mistakes where we don't have ways to trace this and understand this because we've created such this pile of spaghetti of different things talking to each other. We need to think about those, but we shouldn't hold us back. It should just force us to be thoughtful in our planning and how we implement and how we leverage those things.
Thank you very much, Joe. This is, I think, a very interesting view of the future. And I like the way you think of agents as pieces of a system. It was a fascinating discussion. I learned a lot today. And I hope the listeners too. It was great, and I'm really looking forward to sharing this episode with everyone here. And again, thank you very much, Joe, for your time.
Yeah, thank you. This has been great.